Hello again. This is your 11th lecture for Java programming. Today we're going to be covering Chapter 7, Arrays and Array Lists. The Capstone project has been assigned, and it's due Friday, April the 25th, 2014 at 11:59 p.m. Next week we'll go over inheritance and also GUI applications, and then we'll continue in GUI applications and instructor's choice topics and capstone work week for the final week. So I may or may not record a lecture for the final week just because it would help you guys perhaps if you needed help coming in to work on things or get any help or anything. So just one less thing to worry about, and since it doesn't have to do with your capstone, I figured this would be better if I did that. So we'll see what happens over the next couple weeks. So we're getting closer to the end of the semester. We've only got a couple weeks left. We got this week, then 1, 2, 3 weeks, and then we're done. So it's been quite an interesting semester so far. Almost completed, and then you can go on to Java 2 if that's in the cards for you. So today, Chapter 7. A lot to get done. First, let me go over the capstone project real quick, and then we'll dive in. So it's worth 200 points. It's going to apply the various control structures, object-oriented programming techniques, and to work with array lists, which we're going to learn today. So the introduction is for the final project. You'll perform file input using the scanner class and file class, just so there's no lack of clarity here. We're not using JOption pane or anything like that. We're just using the scanner class and file class. The program will load an answer key file, which will be held in a answers.txt, and will allow the user via the keyboard and console output, not GUI input, to enter the name of the student's test file. So you got two different files you're going to be loading. Your program's not responsible for writing the file, for writing any file. Do not write the file with the program you'll turn in for the capstone. So you should write a file in Notepad or other simple text editor in the following format, with the student's answer on each line. So it'll have the student's name at the top, and then you have however many questions there are, and this should match the answer key. So that's a definite. That should match the number of lines in the answer key. So make sure that matches. The file can have any number of questions. It's not limited to 10, as shown in the example. Also notice that the first line will always have the student's name unless it's the answer key, in which case it'll just say answer key at the top. So you'll have a class that you need to implement named student answers. You'll create a separate class from the class containing your main method. So this one should not contain the static main method. This should be a separate class. The student answer class must contain at least the following private data members. If you find that you need an extra one to work with it or something like that that's more convenient, then you can add to it. Don't go insane, because these two are pretty sufficient. You have student name, which is a string, and then student answers, which is an array list of strings. It should contain at least the following public methods. You have the constructor, set student, get student, add answer, and get all answers. You will also have the driver class. This is the one that contains the main method. So in the so-called driver class, you will actually exercise your student answers class by creating objects of that type, of student answers type, and you will store them into an array list of student answer objects. In other words, you'll have an array list of student answers and name it whatever you want, whatever makes best sense. Make sure that you use the new operator somewhere in order to use the array list of student answers. You have to use the new operator. We'll go over that today. You will utilize a loop to ask the user if they want to do another comparison after they finish their first and any subsequent student file load and answer comparison. Before entering the loop, you should read and load the values of the answer key. This is before you even enter the loop that we're focusing on here. You're gonna load those answers into an array list of strings so that that can be used for eventual comparison. During each iteration, that means each time it goes through that loop, you'll create a single student answer object, and then we'll read the student's name into the object. You may use an intermediate variable of some sort to obtain the input, and then place the input that you read into an object via an appropriate method. After you obtain the name of the student, you create another nested loop inside the outer loop that we were just talking about. This one right here that's looping to ask if they want to do another comparison. That inner loop should continue until the file is at the end. So this one's the one that actually reads through the file. Okay. It's done inside this inner loop. At each line, it should ask a single or add a single answer to the student answer created in the outer loop. Once the inner loop is done processing the answers, you end up outside the inner loop, so you're still inside the outer loop. Remember, because there's two loops here, one loop inside the other. So you should add that student answer to the array list that you declared in main. Then you ask the user if they have another student and answers to enter. They should type a Y or a Y for yes, in which case you will continue at the top of the loop. If they type no or no, or truth be told anything but a Y, the loop will terminate. So what do we do with the answers? After you've obtained the answers in the loops for these students and have an array list of student answers, you determine the number of correct and incorrect answers for each student, printing this information out with the student name followed by the correct divided by total equals percent following the student's name. So obviously the correct answers are in the answers.txt answer key file. So this is a sample interaction just to give you an idea of what it should look like when you're done. Please enter the student's name. You put John Baugh. Please enter the file to find the student's answers. johnbaugh.txt. Do you have another student? You can say yes or no. If you say yes, it'll say please enter the student's name. You enter the other name and then the file that their answers are in. Then you can say, for example, like I did here, no, I don't have another student. And then after it's done with this interaction, it'll go through to print out each of their names and their percentages. So the notes and requirements, make sure to use a separate class to contain the answers for a single student. Use an array list of strings inside of student answers class as one of its data members along with the name of the particular student. An object of type student answers represents a single student and his or her answers, not like this John Baugh right here would be contained inside of one single object of a student answer. Jim Snuggle would be another. Since you don't know how many there are ahead of time, you're going to need to use the array list also of strings inside the driver class in order to have the list of the answers. Okay. Also, you need an array list of student answers in the driver class. This will keep track of each of the separate students. So this array list only has 2 in it, but I could go through 20, I could go through 100. It's whatever I want to do. So deliverables, you will submit your code to D2L, turn in both your Java files. So you'll have 2 Java files. One will have the main file in it, driver.java, and the file with your student answers class in it, studentanswers.java. Please keep the names like this: driver.java, studentanswers.java. All right, it really helps me when I'm grading them. I don't have to do anything obnoxious to get it to work. So spend too much time on like each one changing names and doing stuff because everything has to match. The class name has to match the file name and all this other stuff. So make sure that they are the same. That really helps me out. Okay, so if you have any questions, you can feel free to contact me, or we'll add a discussion board here and a new, I guess it's a new topic. Yeah, new topic. Okay, so new topic, we're going to put it under Java programming, and then we're going to call it CAPSTONE project, and I'm going to CAPSTONE project discussion. I'm going to hit save, and you should be able to work with it just fine. So you've got the capstone project discussion now that you could excuse me, talk on if you need to ask any questions there, or you could obviously feel free to email me. The chapter that we're discussing today, Chapter 7, is on arrays and ArrayList class. So Chapter 7 discusses the following main topics. First, we'll do an introduction to arrays and processing array contents. And once we've done processing array contents, then we'll go on to passing arrays as arguments to methods. We'll learn about some useful algorithms that have to do with arrays and some operations on them, returning arrays from methods. So not only can you pass arrays into methods, you can also return them as the return type from methods. We'll do look at string arrays and also arrays of objects in general. Sequential search, parallel arrays, 2D arrays, arrays with 3 or more dimensions. Anything with more than 1 dimension is typically, we refer to it as collectively as a multi-dimensional array. Then we'll look over selection, sort, and binary search. And then we'll consider command line arguments, in case you ever wondered what the string args thing is on main. The ArrayList class also, so that's what you'll need for your project, so capstone project. All right, so introduction to arrays. Primitive variables are designed to hold only one value at a time. So arrays allow us to create a collection of like values that are indexed. An array that can store any type of data, but only one type of data at a time. So we say that it's homogeneous. It has the same, or sometimes you'll hear homogeneous. It's the same type of data. So an array is a list of data elements. So with an array, it's kind of like a carton. If you've ever seen a carton of container of eggs, each of the little slots, it's one carton, but there's slots in the carton, and you put the egg in each of the little basket areas. So each of those would be like what we would call an index. So an array is an object, so it needs an object reference. Keep that in mind, that's very important. Even if it's an array of integers or an array of double and not an array of a reference type, even if it's an array of primitive types, the array itself is a reference type, just like a class. Okay? So it means if it's a reference type, we need the new operator. So the next step creates the array and assigns its address to the numbers variable. So we take numbers, which we declared here earlier. Notice the brackets here. That's how we distinguish between a regular primitive variable, a primitive or single variable, and an array. You put the brackets here when you declare it, and then you say numbers equals new, and then int, since it's the data type, and then in brackets after that, it gives you the size of the array. Array element values are initialized to 0. The indices or indexes always start at 0, okay, not 1. So the first compartment in an array is what we call index 0. The next compartment's index 1, index 2, all the way up to index 5 in this case. Now, why is it 5? Well, there are 6 elements in the array because we're counting from 0. 1, 2, 3, 4, 5, 6. But since we're starting at 0, it goes 0, 1, 2, 3, 4, 5. So that's why it ends at 5 and not 6. So it's possible to declare an array reference and create it in the same statement, just like you would do with a variable. So you have this right here. You'd say int bracket numbers equals new int size 6. That does exactly the same as what happened earlier. Arrays can be of any type. So these are all primitive types. You don't have to make them of primitive types, but these give examples. This would be a float array of size 100. This is a char array of 41, a long array of 50, a double array of size 1200. So that means that this one can hold 1200 doubles. So it's much more compact than creating separate variables each time. Like double 1, double 2, double 3, or age 1, age 2, age 3. You can make an array and then just specify the sizes that way. The array size must be a non-negative number. Since it counts essentially the number of elements in the array, then it doesn't make sense to have a negative number. It could be a literal value, a constant, or a variable. So this would be an example of using a constant. If I say final int array underscore size equals 6, I can then create the array based on array size. Once it's created, an array size is fixed and cannot be changed. Okay, that's important. Array lists, on the other hand, which we'll see, are dynamic and you can change the size. We'll see that a little bit later. So an array is accessed by the reference name, which is the name of the variable, and then a subscript, also known as the index, that identifies which element in the array to access. So each of the actual values that live in the components of the array are called elements. The subscripts are these. So you got 0, 1, 2, 3, etc. So if I want to assign a value to numbers at 0 or numbers sub-0, I would say numbers at 0 equals 20. All right, so far so good. The next thing that you're going to take a look at is that you can input and output array elements. Array elements can be treated as any other variable. They're simply accessed by the same name and the subscript. Also, array subscripts can be accessed using variables, as with loop counters. So we're going to actually take a look at array demo number 2, which is on page 412. So I'm going to go over to my handy project. I've created I created a brand new project right here, lecture 10. And I'm sorry, this should be lecture. I'm going to make a lecture 11. So new Java project, lecture 11. Apparently losing my mind and forgetting what's going on. You know what? Let me do this. Let's do this right. Java project lecture 11 examples. There we go. That's better. That makes me feel a little bit more warm and fuzzy inside. Okay, so you've got the source file here, source folder here. We'll create a new class. Since it's been complaining about the package names, I'm going to say com.lec or com.jpbaw.lec11. All right, and for the name, we're going to call it array demo 2. Hit finish. I get the array demo 2 that pops up here. Public static void main string array args. So now that you know the syntax of what a string array is, this says that this takes a string array as a parameter. Okay, you might wonder, well, where's that array coming from? Well, that has to do with command line parameters that we'll talk about, command line arguments. So for this one though, let's see what we got here. We need the scanner, so I've got to import that. So import java.util.scanner. So once I've got the scanner here, inside of main, I'm going to final int employees equals 3 int hours. So this is my array here. I'm going to make this based on the employees constant. Oops, employees, not employee. And once you do that, you're going to create a scanner. Scanner keyboard equals new scanner based on system.in. And then you're going to do system.out.print line. So enter the hours worked by, I'm going to say employees. You might wonder, well, what are we doing here? Well, what we're doing there is you're printing out, it'll say enter the hours worked by 3 employees. And then we could do them one at a time since we know how many there are, but it's much better if we use a for loop. So I'm going to say index equals 0, index less than employees, and then index plus plus. Right? So that's the name of the for loop there. System.out.print. Now for this one, I want the actual employees to be counted from 1 when I actually relay them to the user. So I want it to say employee 1, employee 2, employee 3. I don't want it to say employee 0, employee 1, employee 2. So the way we can get around this is I can say employee, and then I'm going to put in parentheses index plus 1. I have to do parentheses, otherwise it'll do a concatenation So you want to do the math first. Remember, parentheses overrides everything. So you're going to say, it'll say the first time through, it'll say employee, the index will be 0, it'll add 1 to it, so it'll be index 1. So it'll say it's the first employee, basically. So this is for employee 1, and then you're going to enter, I'm going to say hours at index equals, it'll wait for the next integer that we enter. Right, so we can use the array at a particular index just like we would any other single variable. So it's pretty, it's going to be pretty useful for us to do it this way. So we can use it actually as input or output. So we can put data into it, or we can get data out of it. Either way. Then we're going to say the hours you entered are index equals 0, index less than employees, index plus plus. So I'm going to put hours at index like that. And then if we run it, we can run it now, and you'll see that we are able to put in the information for the employee, say 40, hit enter, hit 20, enter, and 15. And then it'll say the hours you entered are 40, 20, and 15. So this is two incidences where we can get the data from the keyboard, as in here. So it can basically, this hours at index serves as a left-hand argument, or a left-hand operand to the equal sign. And in this case, it's kind of behaving as a right-hand operand. In other words, it's being read from instead of written to. So it's just printing out the data that we find in the particular location at that index. All right, so far so good. So Java does bounds checking. It does what's called runtime bounds checking. So array indices, or indexes, always start at 0 and continue up to the array length -1. So if you create an array of size 10, now don't get confused here, this does not give the upper bound, okay? If you've dealt with a language like Visual Basic, you actually pass in the upper bound, not the size of the array. That gets very confusing for a lot of people who are flipping between certain languages. But most languages, you specify the size when you create an array. So this is the size. But the array has indices from 0 up to the size of the array, or the length of the array, -1. So in this case, since the length of the array is 10, 10 minus 1 is 9. So the valid indexes, or indices, is 0 through 9. They have an example in the book called Invalid Subscript, if you want to look at it. In for loops, it's typical to use I, j, and k as the counting variables. Very, very typical. It might help to think of I as representing the word index. I don't usually think of it that way, but usually they go with I, j, and k. It's often the case that you have you might have one array inside of another, or one loop inside of another, like the ones you're going to be doing for your assignment. Arrays, one of the major things that people have troubles with arrays are called off by 1 errors. And it's extremely easy to be off by 1 when you're accessing arrays. This code has an off by 1 error. So you might declare the array, it's size 100, then you say for int I equals 1, I less than or equal to 100, I plus plus. Well, we look at this right away. The index should start at 0 in most circumstances. So this whole loop is supposed to put 99 in each of the locations in the array. But here's the problem right here. This is what causes the off by 1 error. This is not technically an error. It's just you're not utilizing the position 0, the index 0. So right here, I less than or equal to 100 is where the off by 1 occurs. Now, why is that? That's because the size of the array is 100, so the largest valid index is 99. So 99 should be the last index of the array. So if you run this code, you'll get an array index out of bounds exception. Okay, that name of the exception says it all. How we would correct it is you would put change the I to a 0, or the initial value to a 0. Change this to a 99, or you could leave it as 100, but you'd say strictly less than. You'd get rid of the equal sign. So how do we initialize array? Just like we can initialize any variable, we can initialize arrays. So there are relatively few items that need to be initialized. If there are relatively few items that need to be initialized, an initialization list can be used to initialize the array. So this is what the initialization list looks like. You have the declaration over here, and the compiler automatically creates for you an array. You don't even need to use the new syntax. It'll create an array. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the days array. It tells you how many days are in each month. So January has 31, February has 28, etc., etc., etc. The number of days are listed, are stored in this order right here. So that is one major example of how you could do the initialization list, but it's not very practical if you have an extremely large amount of data. So alternate array declaration. So let's say previously we showed arrays being declared like this. You've got int brackets numbers, however the brackets can also go here. Okay, this is more of a C++ style, but in Java you pretty much always see this. So the first style is more typical in Java. Multiple arrays can be declared on the same line. Okay, so with the alternate code notations, each variable must have brackets though. So if you have this, if you say int array, codes array, and then scores, scores will just be an int variable in this case. What about processing the array contents? Once we have data in our array, how do we process it? So processing data in an array is the same as processing the data of any other variables. So I could say gross pay equals hours at location 3 times pay rate. You can do pre and post increment, works the same if they're on the same line here. You can say it score, initialize it to 7, 8, 9, 10, 11. You can increment, say at location 2, so this is going to take the 0, 1, 2, it's going to take the 9 and increment it to make it 10. It's going to take the location 4, so 0, 1, 2, 3, 4, increment it, and change it to 12. So let's look at a pay array. It's on page 418 if you're interested. I'm going to create a new class here under this package. New class, call it pay array, and hit finish. So we will need the scanner again. So import java.util.scanner. All right. Public static void main string cards. There's our main method. Final hit employees. We're still dealing with the employees here. That's a constant with the value 5. Double pay rate and double gross pay. All right. Then you're going to create array to hold employee hours. So I'm going to say int hours equals new int, and whatever the size of employees is. Then you make a scanner, keyboard, new scanner, system.in. And once you've done that, you're going to get the hours worked by each employee. So system.out.print line will say enter the hours worked by. Okay, and then on the next line, we'll say employees who all earn the same hourly rate. All right. Okay. So, one second. it's going to print out, enter the hours worked by 5 employees who all earn the same hourly rate. Well, index equals 0, index less than employees, index plus, ending the for loop there. Print employee number. Again, we'll do the same thing here. This is pretty much identical to what we did before. It's going to be a little bit different. And hours at index is going to be set to whatever the user enters, so keyboard.nextInt in this case, obtaining integers. Then you're going to get the hourly pay rate. System.out.print, enter the hourly rate for each employee, and so pay rate equals keyboard.next double in this case, since pay rate's a double. Okay. So number of hours is an integer, but the pay rate itself is actually a double. So we're going to take that value. We're going to go through each of them, and we're going to calculate the gross pay and print it each time. So here, the system.out.print line will say here is each employee's gross pay. For index equals 0, index less than employees, index plus. Gross pay equals hours at index times pay rate. Oops. We need that bracket, closing bracket there. And once you get the gross pay, you just say system.out.print line, say employee number. Again, we want it to look like they're being indexed from 1, so you do the little math right here. And then you're going to say $sign gross pay. All right. So far so good. Let's do this. Let's run it. We run it. We'll notice down here it'll say enter employee. Looks like I goofed somewhere. That should be employee number. I'll run it again. So employee number 1 said they worked 10 hours, next worked 20, 30, 40, and 50 hours. This is enter the hourly rate. Let's see what they put there. We'll say it's a $10 hourly rate. Hit enter, and it shows you how much money each of the employees made, what their gross pay was. So it's pretty darn useful. So it's very compact compared to what we would have had to do if we had to declare separate pay rate, like pay rate 1, or pay rate is the same, so that's no problem. But gross pay 1, gross pay 2, gross pay 3, gross pay 4, and hours 1, hours 2, hours, something like that. I mean, if we would have done hours 1, hours 2, hours 3, hours 4, hours 5 as separate variables instead of this nice compact array here, it would have been a lot more sloppy. We can just refer to the entire array as if it were like an apartment building, and each of the indices or indexes, like location 0, location 1, location 2, those are all like separate apartments. Okay? So the next thing, you can, array elements can be used in relational operations. So for example, the value at location 20, if that is less than the value at location 0, do something with the statements here. They can be used as loop conditions as well. So you can say while the value at count is not equal to 0, do something. You can use them anywhere you can use regular variables. The array length. So arrays are objects and provide a public field named length. Public field. So that means it's a piece of data. It's a constant and it can be tested. So right here you have double temperatures equals new double 25. The length of an array can be obtained by using its length constant. All right. So in size equals temperatures.length. Then the variable size will contain 25 because that would be the length of the temperatures array. There's another for loop that they give to you in Java called the enhanced for loop. The enhanced for loop is similar to what some languages call a for each loop, because it basically goes over all the elements of an array that's perfectly made for an array. So the general format is data type element variable, so a single element's data type, and then colon, and then the name of the array. So right here, for example, lowercase, for int val in numbers, since these are ints, each element's an integer. Say for each value in numbers, print out the next value as val. So in this case, you're not directly concerned with the index. You just want to, for example, print all the elements in this particular array. So every time val goes through here, val will get updated each time it goes through the loop. It will equal numbers at the next element in the array, starting with 0 up to, in this case, 0, 1, 2. The length constant can be used in the loop to provide automatic bounding. So instead of having to keep track of the global constant, or some sort of large constant or whatever, or globally available, or passing it as a parameter like you do in some languages, it's actually, the length is actually part of the array. So basically you just say, if you're in a for loop, you say the index I, for example, less than temperatures.length, and then that will automatically bound it. So since index subscripts start at 0, and they end at 1 less than the array length, this is perfect. We just start at 0, and then you tell it to basically, as long as it's less than the temperatures.length, so for what values will it be less than length? What is the last value? Well, length minus 1, because when it gets to length, it will not execute the next time. Okay, that's pretty cool. All right, so the next thing you can do, you can let the user specify the size of an array. So once it's created, you can't really change it, but if you wanted to, at runtime, you say int tests, say I did declare it, but I did not say equals new int array and give it a size. You then create a keyboard scanner. You ask them how many tests do you have, they input it, and then this is where you actually allocate the appropriate amount of memory. If they entered a 5 at the keyboard, this will be new int size 5. If they entered a 20, it'll be 20. Even though you can't change the array itself, except for the individual elements, you can reference a different array. So an array reference can be assigned to another array of the same type. So you might create an array referenced by the numbers variable, and then later on you might reassign it to a different array. If the first array no longer has a reference to it, the garbage collector will come along and get rid of it. So that's actually part of the system. So in the runtime environment, Java will actually collect the garbage, quote unquote, and it will restore the memory that you claimed initially. If there's no more references to it, the garbage collector will say, well, that doesn't have any references to it. We'll give that memory back to the operating system to use, or back to our program. So reassigning array references, they give you kind of an example here. If I reassign it like I did just a second ago, you put it to 5 instead of 10. This one no longer has any references to it, so it gets marked for garbage collection. What about how to copy arrays? Well, how do we copy arrays? So if you create an array here, array 1, if I say array 2 equals array 1, that does not copy it. That means that they point to the same location, the same array in memory. So if later on you actually want to copy it, let's say that you want to do an actual copy, you want this first one, maybe initialization list or some other means, and the second one has to be the same size, then you have to go through a for loop and do each element. So that's how you copy the elements of an array. There's not really a good shortcut in this case. Okay, so passing array elements to a method. Well, we learned about parameters previously. You could pass arguments, actual arguments to a method, and then in the method definition, that argument will take on the value, or the parameter will take on the value of the argument, and you can manipulate the argument in different ways. So more often you'll want to write methods to process array data by passing the entire array not just one element at a time. So how do we pass an entire array? Well, let's look here. We'll create another class, and we'll call it passElements.java. So passElements is the name of the class. All right. So we don't need the scanner at this point, so we're not going to do that. So public static void main args. Inside of here, we're making an array called numbers that has 5, 10, 15, 20, 25, 30, 35, and 40. That's our initialization list there. Then we're actually going to, before we do that, we're going to actually define another method down here, public static void show value. Okay. You can pass it a particular element of the array. This is our first run at this. Then we'll do a more full-fledged one in just a second. So this particular one, pass elements, they're just passing a single element at a time, and whenever they pass it, we'll say system.out.print, and then another space afterwards. Okay, fine and dandy. Make a for loop, int I equals 0, I less than numbers.length, I plus plus. Inside this for loop, we'll call show value on numbers at index. So that's how you pass an individual element. That should be numbers, sorry. That's how you pass an individual element. Goofed that up too. It should be I. You show an individual element of the array, so basically this is just passing in a number. Okay, so if we ran this, it'll print out the contents of the array. But that's not always what we want to do. So what if we want to actually pass the array itself? So in this case, let's create another one called passArray. PassArray. All right. So again, public static void main string array args. And this is the void main. I'm doing that just because we got a lot of code to put. So final int array size is equal to 4. Once we've done that, we're going to create the array. Int numbers equals new int array size. Good. We're going to pass the array to some methods after a second here. Let's define these methods though before we use them. So private static void get values. That takes an integer array, so that's how you actually pass an array to or that's how you actually indicate the parameter is an array. You say int brackets array just like you would any other variable. You're going to create a scanner keyboard. Scanner. I didn't import scanner. I need to do that. Import java.util.scanner. So now we can use it. Now it knows what a scanner is, so that's good. And it's going to be based on system.in. Once we've done that, you're going to say system.out.println. Enter a series of array.length numbers. And we don't have that value yet. It'll be passed in. So when the array is passed in, we'll know how many numbers. So we'll say read the values for int index equals 0, index less than array.length, index plus plus. We could use I here, of course. So system.out.print enter a number, whatever, say index plus 1 in here. Again, this is the same thing we're doing with the employees here. Just making it look a little prettier. When humans look at something, they like to see stuff indexed from 1. So we're just kind of pulling the wool over their eyes about how it's actually displayed versus how they see it, or versus how it's stored. So this is what this method does. All it does is you pass the array in, it prompts the user for values, and you get the values. That's the end of get values there. The comment is just for clarity purposes. show array. Okay. This is the show array. And what we're going to do now is you're going to just print out whatever array they passed in. So int index equals 0, index less than array dot length, and then index plus plus. This is the for loop. System dot out dot print array at index, and then a space. So far so good. All right, so that's pretty good. Let's see what it does if we now call those two methods. So we're going to make this a lot cleaner here. We're going to say get values. So I'm just going to call get values. I'm going to pass in numbers. That's all I'm going to do. And then you're going to say here are the numbers. So system.out.print line. Here are the numbers you entered. I'll show array on that. All right. Okay. Now, if we run this down at the bottom, let's enter a series of 4 numbers. I should actually put a space there, clean it up a little bit. Enter a series of 4 numbers. Enter number 1. Let's say that we've got 2, 4, 6, and 8. And then I'll say here are the numbers you entered: 2, 4, 6, 8. So that's pretty nice, right? We were able to pass the array as a method or as a parameter to this and get the data to store it into the array, and then down here we just use it to read from. Basically, we're printing out the values back to the user. So that's pretty nice. Pretty good way to work with arrays here. So you know how to pass arrays as a parameter now. Again, when we actually do the actual passing, when it's called, we call it the argument, though. So numbers is the argument to this, numbers is the argument to that, and then these are the parameters or formal parameters down here. So, all right. So if we go back to the lecture here. So arrays are objects. Their reference can be passed to method. Now you might wonder, well, how did I modify them in the method? Since they are reference variables, I was able to modify the specific data inside of them. Now, what about comparing arrays? How do I compare arrays? Well, the equals operator determines only whether array references point to the same array object. It does not test whether they all contain the same elements. So even though these two contain the same elements, they are not pointing to one another. Okay, I didn't say first array equals second array or second array equals first array. So they are not pointing to the same location. So this is a mistake down here. This right here where I say if first array equals second array, it's going to say the arrays are the same. It's not going to do that unless they point to the same array in memory. So even though these two contain the same items, this one's actually going to print out the arrays are not the same. Here's the example they gave. First thing you can determine is if the arrays are the same size. If they're not, you automatically know they're not equal. While arrays are equal and I less than first array dot length, you can move through this loop here. If you ever find an element that doesn't match, in other words, if this was a 3, if you ever find an element that doesn't match, you set array equals equal to false, and then you can immediately break out of the loop. So that's one way to do it. Keep incrementing. Or if you get all the way to the length. If you get all the way down here and array equal was never set to false in any of these locations, so at any point, if this was set to false, then you not only break out of the loop, but you also do the test down here and then say the arrays are equal or not. So you do have to go element by element, essentially. And there are other ways to write this, of course. But, there are useful array operations here they give you in the book. If you want to find the highest value, well, the way you do it, no matter the size, you assume that the first number is the highest. Then you start at the second number, which is at location 1, go all the way up to the end. If you ever find a number in the array greater than what you have currently set as the highest, then that's obviously not the highest number anymore, so you set highest equals to that number that you found that was bigger. So by the time you get to the end of the array, you will have the largest number in there, because this will only swap, or this, not swap, but this will only contain the value of the numbers at I if it finds one that's at a particular location that's higher than the one it just found. So by the end of the array, you know that it's globally the largest. Same thing with lowest, except you just switch the sign here. It's essentially the same code everywhere else. You start by assuming that the lowest value in the array is the value at numbers at 0. It could be the largest, no one knows, but you assume that's the first one you've looked at. So you're saying, well, this is the lowest so far. Then you go through starting at value 1. If you find one lower, you make that the new lowest and keep going. If you find another lower, you make that the new lowest, etc. So other useful array operations. To sum array elements, you could set a total here. You go all the way through the length of the array and just say total plus equals units at I. This is exactly what you would do essentially if you were, had individual variables that you were pulling in from the keyboard or something, or a file. Averaging array elements. Once you get the total, this is essentially the same thing you see up here, except the difference is down here. You eventually calculate the average equals the total divided by the scores.length. So that gives you the average. Partially filled arrays. So typically, if the amount of data that an array must hold is unknown, so that's usually the case, the size of the array to the largest expected number of elements, and then you want to use a counting variable to keep track of how much data, valid data, is in the actual array. So it's often the case that you say, well, I know I'm not going to have any more than 100, but I'm not exactly sure how many there will be. You can make the array size of 100, and then you use a counting variable to keep track of how much valid data is in the array. So in other words, what is the actual valid size of the array? So you go through here, take an input number here. -1 means I want to break out of the loop or not go into it to start with. So you take the array count at number, or at count, array at count, and then you set it equal to the number that the user entered. Increment the count, and then again you ask them to enter -1 to quit, get the value, keep going through the loop. As another note, this right here, notice this data is essentially a copy of this data. You might wonder, well, why are we doing it this way? Well, they might not even want to enter the loop to begin with. So if you put a -1, it'll just go past here. So this right here has a special name. It's called the priming read. So basically, it's kind of like when you take a pump of some sort, like the gas on a lawnmower or different types of mechanical instruments. They call it priming the pump because you put a little bit of oil or gasoline or something into whatever you're priming, whatever the fluid of choice is or fluid that's necessary. So they call this a priming read. Okay, it's the first read before it goes into the loop. Arrays and files. Again, you can easily work with arrays just like you can, or you can print out data from an array or get data into the array from a file, whichever way you want to do it. So you've got print writer output file with this new print writer at values txt. You go through here, and then you've got output file.close at the end. You want to close it just like you always do. Reading the contents of file into an array. So in this case, you create the file and then create a scanner based on that file. And then as long as the input file has next and I is less than the number's length. So in this case, you've got two boundary conditions. So one of them could be the file ends. The other is, well, what if there's more data in the file than my array can handle? Well, you want to break out rather than crash, right? You could put error conditions and all kinds of stuff in there if you wanted to, but we'll assume that we're good here. So as long as input file has next and the array number's length, as long as it's less than the size of the array. So if there's 10 elements in the file, this one will end up causing the loop to break before this one. If it has maybe 5 elements in the file, but this right here has 10 as its size, then this one will be the one, has next will be the one that will cause this loop to eventually terminate. So we know how to get data into a method by passing the array as a parameter, but how would we get data back from the method? So in this case, what you can do is you can actually set it as the return type. There's a double array there. So you can create the array inside the method if you want, and then return the array. That's fine. String arrays. Arrays are not limited to primitive data, so you don't just have to have float arrays and double arrays and int arrays, etc. You can have string arrays or arrays of any types of object. But remember that the array actually is an address that points to a list of, in this case, locations or elements at different indices. If it's an object type like string or any other object type, you'll note that these are specifically addresses, and then they point to the actual value on the heap. Okay. If initialization list is not provided, the new keyword must be used to create the array. Okay. The names variable holds the address to the array. And when you start out, these will all be null. When an array is created in this manner, each element of the array must be initialized individually. Okay, so you want to say something like names at 0 equals Bill, names at 1 equals Susan, etc. I think they might have jacked up this image here. These should say address now, not null. So calling string methods on array elements. So you can take string objects which have several methods we've kind of looked at before, to uppercase, compare to, equals, and then char at. Each element of a string array is a string object. Okay, so methods can be used by using this array name and the index as before. So this works the same way that you're used to as far as using it on regular variables. You just have to use an index, the indices this time. So names at 0. Let's say names has Bob, Sally, Sue, and Joe. Then you're going to have names at 0. That'll give you the first name in there. So this returns a string. And then say dot to uppercase. You can put any method on the string or any other object you have in there that object supports. So in this case, string objects have to uppercase, char at, and things like that. You can use any of those, just like you could on a regular plain old variable. So the length field and the length method. Arrays have a final field named length. String objects have a method named length. Okay, so they're a little bit different here. To display the length of each string held in a string array, you would say names.length. But then, you would go up to names.length. That's the field of the array, which is named names. Here, you have system.out.println names at a particular location. That returns a string. To get the length of each string, in other words, how many characters are in it, you have to use the length method. So try not to mix those up. The field does not have parentheses. It's a field, not a method. You make sure to write the parentheses when it has to do with the string's size. Okay. Because strings are objects, we know that arrays can contain objects. Well, we can make any object on our own. If we want to make a bank account array of different bank account numbers, you could do this to create the actual array. But when you create it, all of these will be null to start with. Later on, though, to create each individual element in the array, you have to do it one by one. Best way to do it. You go through the loop, you say equals new bank account. What that does is it creates an address for each of these and actually creates one of these in memory. Because remember, when you create the array, all it does is it creates enough room to put the addresses to bank accounts in this case, or balances, or people, or horses, or cows, or whatever your object is, but it does not actually create those elements. You have to use new again in this case. So look over here, we use new in this case with the brackets because we have to declare that we need that many elements in the array, 5. But over here, this has to do with creating the individual elements of the array. In other words, what the addresses are going to point to. You have to say, use the constructor of bank account. There are different types of searching algorithms. Searching and sorting are two major topics in programming languages. Sequential search is a quick and dirty way to search through a small list of items. It could work for larger lists of items, but it's not going to be very efficient. But it is a pretty easy one to understand. So searching and sorting are two of the major ones. Algorithm categories that we learn in computer science. A search algorithm is a method of locating a specific item in a larger collection of data. Okay, let me say it again. A search algorithm is a method of locating a specific item in a larger collection of data. Sequential search uses a loop to sequentially step through an array, compare each element with the search value, and then stop if the value is found or if the end of the array is encountered. So if we go through an array and we never find the element, that means that you'll get to the end of the array and you never found it, so you tell the user, hey, we didn't find it. If you find the value, you can break out immediately and say, hey, we found it at this location, or what have you. So what about multi-dimensional arrays? So 2D arrays are some of the multi-dimensional arrays that we can deal with. A two-dimensional array can be thought of as an array of arrays. So each element in the first array is basically an address to the second array. But you can think of it more visually if you think of it as rows and columns. Okay, so the columns, like the Greek columns, they hold up the top of the Parthenon or Greek different Greek buildings, ancient Greek buildings, and the rows go this way, okay, left and right. To declare a two-dimensional array, it requires two sets of brackets and two size declarators. The first one is for the number of rows. Second one is the number of columns. So right here we would say double and then two brackets here, two sets of brackets, name of the array, new double, and then two sets of brackets again, number of rows, number of columns, so 3 by 4. So that would be 1, 2, 3 by 1, 2, 3, 4. So we'll have this last one. The two sets of brackets in the data type indicate that the score variable will reference a two-dimensional array. That's why we need 2 here. If we have a three-dimensional array, then you'd want 3. Notice that each size declarator is enclosed in its own set of brackets. How do you access 2D array elements? Well, when processing the data in a two-dimensional array, each element has 2 subscripts instead of just 1, like we've been dealing with before. So it has 2 indices. One is for its row and one's for its column. So we would say that at row 1, column 2, this is the element row 1, column 2. So whatever that returns, if let's say it's a 2D array of doubles, then that's the double at location 1, 2. If it's at location 2, 1, that's here, row 2, column 1. So we call this row major notation. We go by the row first, then the column. So this gives you an interesting look into this. If it's initialized to 0 to start with, accessing one of the elements in the two-dimensional array requires the use of both subscripts. So if I say I want to set scores at 2, 1, so row 2, column 1, so row 0, 1, 2, column 0, 1, to 95, you do that, and then this data will now look like this in the 2D array. Programs that process two-dimensional arrays can do so with nested loops. For example, to fill the scores array, you could use the outer loop. This is the number of rows. And you can use the inner loop. This is the number of columns. So this is a very useful way to do it because you can just set the row. The row will change less quickly than the columns because the columns loop is on the inside. It'll go through 0, 1, 2, 3 before you get to the row 1. 0, 1, 2, 3, and then row 2, 0, 1, 2, 3, and then it says 3, so you break out. So this is actually a really, really cool way. I would definitely recommend playing around with this so you're familiar with this and comfortable. To print out the scores, again, you could use a nested loop here. Rows and columns, 3 rows, 4 columns. You could say print line of scores at rows call. All right. How do you initialize a 2D array? Well, there's multiple ways to do this too. You can initialize a 2D array. It requires enclosing each row's initialization list in its own set of brackets. So this is the first row right here. This is the second row. And then this is the third row. All right, so row 0 would have 1, 2, 3, 1 would have 4, 5, 6, 2 would have 7, 8, 9. So this declares an array with 3 rows, 1, 2, 3, and 3 columns. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so 3 rows, 3 columns. Sometimes when people initialize it, they write it like this so it's more clear what's going on. So the first row has 1, 2, 3, next one has 4, 5, 6, and then the next one has 7, 8, 9. The length field, two-dimensional arrays are arrays of one-dimensional arrays. So the length field of the array gives the number of rows. Each row has a length constant that tells you how many columns are in it. So this gets a little bit squirrely here, but numbers.length will tell you how many rows there are. So it's 1, 2, 3, and then the numbers at a particular location, at say row 0, this one will return 1, 2, 3, 4. This will return 3. This will return 4 again. And then you can print out a particular value at that location. How do we sum the elements of a 2D array? Well, just like you do for a 1D array, you just have to reference both rows and columns using a double for loop here, and then print the total at the bottom. Or do whatever you need to do with it. Summing just the rows of a two-dimensional array. Sometimes you just want to know what's the sum of this row, what's the sum of that row, what's the sum of this row. So you're going to take the outer for loop here, go up to the numbers.length, which gives you the number of rows. Set the total equal to 0 each time because we're resetting it. Go through the columns, total up that particular row, print out the row after you're done with it, and then you're going to go to the next location, so row 1. So this one's going to reset total again. Right? How do you sum the columns? Well, same thing, except now you put the columns on the outside instead, and the rows on the inside. All right? So in this case, you total that particular column, and you reset the total again, and go to the next one, go to the next one. So as long as you have columns here, you can total the columns that way. So there's no difference between passing a single or two-dimensional array as an argument. The method must accept a two-dimensional array as a parameter, obviously. So there's a concept of a ragged array in some programming languages like C#. They call it a jagged array, so it's essentially the same thing. When the rows of a two-dimensional array are of different lengths, the array is known as a ragged array. So you can create a ragged array by creating a two-dimensional array with a specific number of rows but no specific number of columns. And then later on you create the individual arrays here, individual rows. So this one says there's going to be 4 rows, but I didn't specify how large they are. So then later on you have to do each one. And I'll say the first row is going to be size 3, next one's going to be 4, next one's going to be 5, next one's going to be 6. So if the columns do not all match one another, even if there's one that's out, it's called a ragged array. What about more than 2 dimensions? So we're starting to get into all kinds of crazy Star Trek type stuff now. So what kind of dimensions can we have when we have our arrays here? Well, you can have more than 2 dimensions. Java doesn't limit the number of dimensions that an array may be. More than 3 dimensions is hard to visualize, though, but it can be useful in some programming languages. So for right here, you can think of rows, columns, and then each one's a page, or you can think of it as a cube. If it was a cube, you would have the height, width, length going on. So it's kind of an interesting way to visualize it here, but once we get past 3, it's much more difficult to define. I said that the sequential search was one of the searching algorithms. There are many, many different searching algorithms. There's also a bunch of different sorting algorithms. So sorting is another technique that we're very interested in computer science. Sorting is done quite frequently. It keeps data organized, and therefore in many scenarios it makes it easier to access. So in what's called selection sort, the smallest value in the array is located and moved to the element 0. Then the next time through the array, it's going to go to element 1, element 2, element 3, etc. until you have all the elements in order. So what it means by calling it selection sort is that you're basically selecting the next minimum element. So you're going through the entire array the first time through, starting at element 0. You look through the entire array, you find the smallest element in the entire array, and if it's not the one that's currently at 0, you swap it with the one that's at 0, and then you move on to number 1. So you're guaranteed the first element at 0, is in sorted order. The next smallest value, you look through again, starting at 1 all the way to the end, find the minimum, then 2, then 3, then 4, all the way to the end. And then if you repeat this process, you will get a sorted array. It's a really interesting sort. I recommend you check it out, selection sort. Demo, it's in the book. Binary search, this is a better search in many scenarios than sequential search that we looked at earlier, but it only works on an array that's already sorted. So you need a sorted array, in this case one that's in ascending order, starts with the element in the middle of the array. This is kind of how you search through a phone book. If I tell you to look up someone whose last name is Oscar, you're probably not going to start in the A's and then look at every page. Obviously we have Google, but let's assume you're locked in a room with a phone book. If any of you know what a phone book is still. I know that's kind of old school, but if I tell you to find this particular person, and I tell you the O's, and they're all in alphabetical order, you know you're not going to start at the first page. You're going to kind of flip to the middle, and you're going to say, is it less than or greater than the stuff I'm seeing now? Let's say you flip to the M's. You say, well, it's after the M's, so I'm going to flip more to the right. So that's kind of how binary search works. If you find the element, you start with the element in the middle. If that's the element that's the desired value, this is one of those lucky circumstances you flip exactly to the name that you want, and then the search is over. Otherwise, the value in the middle is either greater than or less than the desired value. So basically, you eliminate all the elements that are not considered. So in the example of the phone book, if I tell you the person's last name's Oscar, or Oscarson, then you can look in the phone book, and when you get to the M's in the middle, we'll say around the middle, you'll say, well, anything before the M's is obviously out, so because O is not in there. So I destroy that, let's say, or I pretend that part's not there anymore. So I just eliminated half of my search criteria. Then you could flip to the middle of what's left, look in the center and say, well, it's not after this letter, so you eliminate the stuff greater than that, and then you keep narrowing down until you find the element. If it's greater than the desired value, search in the first half. If it's less than, you search in the last half. Repeat as needed while adjusting the start and end points of the search. So basically you're eliminating huge parts of your search area each time because the list is sorted. A Java program can receive arguments from the operating system command line. So you have actually seen this before, or you've been typing this several times. So you've got string args. The main method receives a string array as parameters, and the array that's passed into args comes from the operating system command line. So if you started up your program with from the command line, or you maybe even had a shortcut, I've seen people do that before, done it myself. You can create a shortcut with the command line's arguments built in. Or in Eclipse, you can actually, we'll call this args here. And we'll show you how to do it here. Public static void name string args. Now, args is not a magic name. I could call that sausage if I wanted to. It doesn't matter. But args is the traditional name that you see in pretty much everything. It just means arguments. So the command line arguments that are passed in. So if I want to do the arguments, I'll go to Run. And then I'll go to Run Configurations. And for this one, I want to make sure I'm on args. Okay, it's the current one. I go to Arguments. I'm going to put chocolate space vanilla space strawberry. Then hit Apply. Hit Close for now. Now I'm going to say system.out.println. I'm actually going through a loop there. I'm just going to print out args at I equals args at location I. Oops, need to concatenate that there. Okay, take that off. We run it. Didn't do anything this time. I think I have to go through the run configuration. We'll do right click, run as run configuration. I think I have the wrong location here. We'll say chocolate, vanilla, and strawberry. Hit apply, then click run, and you'll notice down here we have args at 0, args at 1, args at 2. Those are the command line arguments. If we were to run this binary outside of Eclipse, then okay, so this is named args since I'm in lecture 11. So if I go to my work dir here, I look for lecture 11 examples. Go into bin from prof.jpb. I have this thing called args.class. If I were to run that from the command line and pass it in arguments, then I could very easily see, I could just say the name of the class, space this, this, and this. Okay. Okay, you can also make variable length argument lists for any method really. You would say int ... numbers, and then you can use that. This is called a var_arg parameters. These are actually arrays. So basically, it's an array. For each of these, this would be the particular location at that location in the array, or in other words, the number command line parameter that we're using at any individual time as it's going through the loop. This is the one you'll need for your CAPSTONE projects. You're probably interested in this. The array list is similar to an array, but an array list allows object storage. Okay, unlike an array list object automatically expands when a new item is added and automatically shrinks when items are removed. In order to use it, you need to put import java.util.ArrayList. Okay? Here's how you create one. You say an array list, and then in angle brackets, you tell it what type are you holding. For example, for your assignment, it was student data or student grade or student whatever. And then you have the name of the array list, and you say equals new array list, and again, you put the type, and then open close parentheses. All right? If you try to store any other type in the array list, an error will occur. To populate the array list, you can use the add method. So I'm going to say namelist.add, and call it on different names, and get the current size by calling the size method. So instead of length, you call it the size method. To access items in the array list, you use the get method. So you've got add and get. You can also do other things like remove. If I want to remove a particular element at a particular location, I can do it that way by passing in the index and the location I want to remove it at. Automatically, there's a toString method that returns a string representing all items in the array list. So it automatically calls toString on here, and it'll just print it in brackets like this. ArrayList class add method with one argument adds new items. To insert items at a location of your choice, you can use the add method with two arguments. So you pass the index first, comma, the element you're trying to add. Okay, so the index comes first in this case. An array list has a capacity, which is another number. It's different than the size. Okay, it means the number of items it can hold without increasing. So the default capacity when you create an array list, if you don't specify a parameter here, it'll create it big enough to hold 10 items. When it gets to the 11th item, or in this case, since it starts with 100, when it gets to the 101st item, it's going to resize. Right? You can store any type of object in an array list. So bank account, for example. Array list of bank account list equals new array. One second, sorry. New array list of bank accounts. Then you call add on each element, or add, and then you pass it a new bank account each time. See what we're doing here? You have to actually create a bank account since it's expecting to hold bank accounts. Or And then you can display each item. You can use this account as a temporary holder, and then just get. So what this does is it returns basically the address at each location. You could modify it in this format, but in this case they're just calling account.getBalance on each one. You could put list.getIndex.getBalance also. That would be another thing you could do. And then the diamond operator. Beginning in Java 7, you can use the diamond operator for simpler array list declarations. No need for the data type here. They goofed. That arrow should be pointing over here. However, it's probably the best the best thing if you do put it there too, especially if you're using a compiler pre-Java 7. But I just do it because I think it's more explicit. It's a little cleaner. I think it's clearer what you're doing. So string list equals new array list of strings. Java 7 is a newer version, so if you don't have a compiler that supports it, don't even do this. But it's not going to hurt anything if you write string in here too. So again, if you have any questions, please contact me at jpbaugh@umich.edu. Please feel free to contact me over email, or we'll have a discussion in the discussion group. So have a good day, and we'll see you next week. Thanks for tuning in.